Hey everyone, Brian Beeler here with Storage Review, and today we've got another deep dive, a demo of a solution that Supermicro has been working on that's really pretty cool. Now, we just did the piece with you on SuperCloud Composer and went deep there, and you're going to hear a little bit about that solution in this one. But I've got a number of guests with me today to make sure we do this justice, do a good service here, because what Supermicro is doing with these solutions that are more than just pushing out servers is really kind of a fundamental shift to the overall business model. They're really coming together with more solutions-oriented focus, and this one's on OpenShift, and I think it's very cool, very compelling when you talk about taking the easy button, if you will, and applying it to Kubernetes at the edge, all sorts of different use cases here that are really pretty cool. So let me bring in my compatriots here. We've got Tom Fenton up in the upper right-hand corner, Michael Ocampo, bottom left, a Supermicro expert, and Jeffrey Tu, another Supermicro expert down there in the bottom right. So Michael, I just set it up briefly for you there, but the solutions that you guys are putting together, in this case around software defined, is really pretty impressive. Give us the highlight of what you're doing with this particular program.
Yeah, absolutely, Brian. Thank you so much for having Jeffrey and I on this call. We're very excited to talk about our OpenShift Kubernetes cluster on bare metal. As we talked about before, most customers are deploying software-defined solutions on top of a hypervisor, and above the hypervisor is, usually Kubernetes or file systems and additional services here. So what we're trying to do is give customers an option to really diversify their infrastructure. So I just finished watching the Intel Innovation event, and they talked a lot about how computing is moving to the edge, and it's not compute that's growing in just the edge, the data center as well, core, and then all the different layers to the next wave CSP layers. They're all, everything is being, modified or enhanced, if you will. So I think Kubernetes and our partnership with Red Hat is very important for us to kind of play into these different market segments with our partners as well as and customers, enterprise customers. So what we're showing here today, as you mentioned, SuperCloud Composer is a piece of the puzzle here when it comes to the gateway. So we're running that in this cluster, and you can see here we've got our X12 Big Twin here. So that's our SYS 220BT-HNC8R. And what we're doing with this is providing a way to deploy Kubernetes with Red Hat OpenShift to provide enterprise support for a cluster. And so customers are really wanting to have cloud native application support. And Red Hat offers great consultancy services to enable customers to do that. There's a lot of legacy code out there, and customers are making that shift to containerized applications. And when they do, they're going to want to have something like this so that they can get as much performance out of the application as they can without paying the hypervisor taxes. So here you can see there's actually 3 nodes here. So the first node here is node A, and you can see we've got a 6336Y CPU. And we have basically 2 terabytes of memory here. And that's because we have the Intel PMEM 200 series. And we have 16 VIMs, and 8 of them are PMEM. And so the nice thing about SuperCloud Composer, just to kind of re-emphasize some points here, it's great for asset management, looking at components, looking at the BIOS and BMC version. So lifecycle management becomes much more seamless because you have this one kind of gateway for all the different subsystems. So here's A, here's node C, here's node B, and this is the foundation for an HA. environment for OpenShift. Usually, when customers are really wanting to scale out, then they may want even more high availability where they'll have three masters, three infrastructure nodes, and then four more additional worker nodes that are separate. What we've done with this solution is we have the controller as well as worker nodes that are they're coexisting in the same node. And we have local storage here. This X12 Big Twin can support 24 NVMe drives. And for additional storage, we have three Ultra systems. So you can see here the 1U Ultra here, system 120U-TNR. These are running 8350Y processors. Not as much memory, but it's sufficient for what we needed to do as a S3 object storage endpoint. So any questions about this before I get into the OpenShift cluster itself?
Well, real quick, Tom, I know you're going to jump on this, but I want to hit on it too, because you sort of casually went through these components. But what's important, or one thing that's important about what you're doing here with the rack plug and play infrastructure is that this is relatively small, right? I mean, you talk about edge, and to be able to, if you're like a CDN, for instance, where you might want to have a couple of these in different regions, pretty easy, and you're giving customers the ability to package these up into kind of infrastructure to go, I believe. Is that true?
Yeah, so we are able to deploy the whole rack. So it could be as small as a 3-node cluster or even a whole 42U rack. But I think for a lot of developers that are, really power users, where they want to have their own resources that are local to them, think about content delivery networks or post editing studio or broadcast station where they want to have local compute. We have partnerships with Weka IO for things in the biopharma. They're also working with a lot of telecommunications companies as well to improve the file system performance. But we also work with Accelero, for example. Accelero, they have good partnerships with media groups. So those type of broadcast or post-editing partners that we work with, they want to have local resources on-prem that's working with the workstations and GPU servers to do a lot of rendering. So that's a really very important and prevalent use case that we support.
I noticed on some of the server nodes that you said that you had PMEM on that. What was your design decision in going with PMEM?
Yeah, that's a good question. So we actually are working with cloud hosting companies where they want to have more gaming instances. So when they do the cost comparison of just standard DDR4 versus PMEM, they're actually able to double the memory footprint for the same cost of DDR4. So this one is showing two, but most of the time we'll see something like this where they'll have 4 plus 4 per socket. So in total, it would be 8 128 gigabyte PMEM modules. This is PMEM Series 200. The mega transfers is rated for 3200. So this is a huge difference than when X11 had PMEM, which was the AKA as AEP. So now it's Barlow Pass. That's the code name. The original AEP was derated to 2666 megahertz. So a lot of customers, they didn't really jump onto PMEM because it really hurt the performance. There were some people that were using virtualization with the first generation of PMEM, but now, because the performance is very strong, it makes more sense to use PMEM in many other workloads, not just for gaming, but any kind of virtualization or software-defined solution. I think a lot of customers should consider it for higher memory capacity per VM.
Yeah, so you're getting, you know, good performance, obviously not as good as real memory, but for half
Yeah,
the price, right?
that's right. Yeah. So
Yeah.
DDR4 becomes basically cache. It's not
Yep.
the system memory, but it would be operating at the speed of the PMEM itself. And considering we have 16 DIMM slots per node, that basically means you're getting the performance of 8 or 4 PMEM per socket. So it's not as good as, let's say, you fully populate every single DIMM slot with DDR4. So the performance degradation, don't quote me on this, but it could be 30% lower. But in most cases that we've seen, that seems acceptable for virtualization.
Sure. Yeah.
All right. Well, let's get into the meaty stuff around Kubernetes and see what you've got going on over there.
Okay, sure. Alrighty. So in the OpenShift cluster, I'm in the administrative overview tab. So for administrators, this is a very important interface because they can see the bare metal information, the number of nodes that are inside the environment, their cluster utilization, and they can actually change the time series database parameters. So the interval here is 1 hour, we have 6 hour, or even the last 24 hours. So this cluster has been relatively idle. So you can see that the utilization is very low here. But we do have a lot of resources that handle a lot of different things. So one of the demos I'm going to show you is running just a basic web server that's doing video on demand. Before we get there, just want to kind of show that we have 200 pods that we can support. So basically, we have one pod that's handling the demo environment, which is the same environment for the Jumpstart program that we are supporting. So customers can sign up through and then log in through a VPN and gain access to the very same cluster that I'm using right now. Within this overview, there's a tab for events. So this is also very important to understand what's happening in the cluster. So we have an Nginx container that is handling the web serving of the website that we built, for example. And a few other things to mention here before I get into storage is there is an operator hub. So Red Hat supports something called an operator framework. So this is very important for DevOps because there's a lot of dependencies for the applications that are running. So let's say, for example, you wanted to do data exploration. So you could install Redis very easily. I can click on this, I can hit install, and that would get installed across the whole cluster, the whole Kubernetes cluster. So this is very popular amongst lots of different mobile applications. So Twitter is a big user of this, Netflix as well. And another interesting database that you could use in addition to Redis is something like Apache Cassandra. So that can also be installed as well. So very easy to manage, stateful applications that handle, a session anchor and then even stateless functions as well.
Yeah, those operators really are game changers for people who are just new to Kubernetes, right? Because these you just kind of install and it manages it. You don't have to, I mean, back in the day, you had to just go through so many hoops to get things up and going. And with these operators, they just kind of plug and play, right?
That's right. Yeah, so even the storage piece of it now, the OpenShift container storage, so we do have a license that has been unlocked for us to set up either block and file on the local cluster or even object storage on the cluster, even or provide a gateway for external S3 services. So in this snapshot, you can see the utilization for the use capacity, IOPS, latency, throughput. And then you can also change the interval as well to kind of look at the time series database for just the storage itself. So the nice thing about this for an administrator that may be supporting a DevOps team is there's lots of different applications that may be running. So here's the Nuba management console, which is basically part of the multi-cloud gateway. So this is a subset of the object storage gateway. And so you can see here it's very easy to review the storage here. So this class or bucket that has been defined as other S3 is actually the local object storage cluster that's running on the Ultra. So 3 Ultras are replicating the data by 3. And so let's say I wanted to pull in another resource. I can go into add a resource, click on add cloud resource, and you can see that we've actually tested other S3 endpoints like a scalability test, and then we even tested a Ceph objects gateway. And so here's another. I can add a new connection here, and so I can configure an AWS S3 or Azure Blob or Google Cloud Object Storage as well. If we get into the buckets here, you can see the Jumpstart program here, and you can see that we have a replication here. We have 1 copy. If I jump into this, you can see that we have potentially up to 1 petabyte, but that's not how much we have. It's just that is the maximum for this particular configuration. And I can edit this resource. So right now, as I mentioned, it's set up in replication mode, but you can also spread it out. So let me kind of share a different configuration here. So I can go to edit data resiliency, and then I can change it from replication to erasure coding. So you have 4 data and a 2 parity. And it tells you your storage overhead, fault tolerance, and a minimum requirement to ensure that you don't lose any data here. So that's all I really want to share with you here. Are there any questions so far before we get into the demo?
Yeah. So with being able to expand out to S3 or any of the other providers, storage is infinite, basically, right?
Yeah, I mean, you have access to the data that you're paying for, essentially. So it's
Yeah.
And it really depends on the use case of how you want to configure it. Right now, we are set up for internal storage mode, which means any additional storage that we add to the cluster would just be an S3 endpoint. But let's say you want to have a container storage interface and you want to run external mode, then the cluster would have to be configured in such a way where the object storage can kind of tier out. So if you needed to, let's say, do the video stream and actually pull from a tiered storage, or let's say even analyze all the data in real time to then provide recommendations, for example, then that would be a different config, and that's not what we're showing here today. We're just showing that there's a S3 endpoint that we can easily access from this portal.
Hey,
So
before you jump into that demo too, I want to at least do a real high level on your MinIO integration as well, because I know that's a pretty big deal for you.
Sure. So the objects that we have here, you can see that I'm about to show you the video on-demand demo. So this is actually where all the objects are located. So we have the videos in different formats, 1080, 240, 360, 720. We also have some VTT files for the subtitles. But how do you manage it? So a lot of our customers and partners are really interested in the MinIO browser. So this is just a browser, but there's actually an operator for this to make it very easy to install across the cluster. But here we're just showing the interface to manage the storage. So I could literally just drag and drop the data in here, and I can download it, I can share it. So if I want to set a limit, even down to the hour, you can do that, or even just 5 minutes for maximum security. And the other thing for our users is when we have these engagements where customers want to test it out, they may have 5 developers or more. So we've already predefined some buckets for that one account or one customer to kind of isolate projects on the customer side. So this is a very easy way to manage the storage. And then once the data gets populated through this browser, then it will syndicate across the multi-cloud object storage gateway interface here. So it's very easy to add or remove data. All right, so if we go into the actual developer perspective, this is where the magic happens. So you can see here, we have a lot of different applications here. So we have the Nginx video on demand module running in a container. And the nice thing about this is we can go to the edit source code. So this will bring you to Jeffrey 2's GitHub account. So Jeffrey is our senior solution architect on the team, and he's done a great job in just providing a good example for running a non-root user container for the Nginx VOD module. All right, so you can look at that by just going to GitHub. So pretty much anyone that has a GitHub account, or even if you're just a visitor, you can take a look at his code. And he is pulling this data from other branches of code, and he's customized it for this demo. In addition to that, he's got the MinIO browser that I just showed you. So that's running in a separate container. And then we have the actual source code for the website that we built for the demonstration. So this is actually a Docker file. And you can see we have various assets in here and pictures. So you'll see that the website that we built is further explaining and reinforcing the whole concept behind this. So customers can easily test their cloud native applications, such as a video on demand website. So here's just showing you, what is the makeup and structure of this container. So if I click on this URL button, it will bring up the website that we've built. So if you look down here, we kind of explain it, right? So everything that I just showed you conceptually, the various applications can actually gain access through the S3 API. You have different buckets that can come from different environments. It could be multi-cloud, strategy to offset the cost of on-prem resources. So for our case, we also have a backstore that we're replicating this information. So when customers log into this environment, they have a very easy way to kind of understand what's going on here, how to configure their storage, and then what is the actual hardware involves. So I already mentioned the X12 2U400 Big Twin. One of the nodes is actually isolated out, and that is running the SuperCloud Composer, as well as Bastion services for the OpenShift cluster. And then we're using our own 100 gigabit switch here. So I'm going to pause the video here. So we are using our own switch hardware as well. And you can see it is handling the S3 over 25 gigabit. And then the cluster is being managed by a 10 gigabit switch. And then for the BMC, it's also on 1 gigabit. So the BMC is actually in yellow, the 10 gigabit is in red, and then in blue is the 100 gigabit. So this is for the local block storage across the 3 Big Twin nodes, whereas the S3 endpoint would be over 25 gigabit. So that's the hardware side. And then there's a little bit more information about how to access the other services and what are their use cases, right?
Well, so what when you guys, I mean, there's a couple things. Obviously, the hardware is pretty neat. The way you guys have bundled it together is great, and the fact that it's a vertically integrated solution is pretty strong too. But one of the tricks, and you know, I know from being in the space, Tom was just at KubeCon and talking with a lot of people in this space. One of the tricks is just getting hands on with some of this gear, and that's not even a supply chain issue. I mean, it just fundamentally can be challenging to set up. So you guys have the Jumpstart program, which I think is important for solutions like this. Can you spend a minute on what Jumpstart is and what you're trying to do there?
Sure. So the idea is to help customers really understand what systems have been validated. We have such a large portfolio of products, and we want customers to be able to be comfortable with the solutions that we have. I mean, I can't tell you how many times or customers come to me and they ask, has it been validated by ESX 7.0 version, past U.U3? And I say, yes, that's one of the first things that we do. But then we take it a step further and we say, well, we can even run Tanzu above the hypervisor. So, that's where customers are actually coming to us now is Red Hat OpenShift has become very popular. And they may not want to run again, on top of a hypervisor. So we're showing them that you can run on bare metal, right? So as long as you're very deliberate in planning the resources, there's nothing stopping you from running Kubernetes on bare metal. In fact, I think that is a growing initiative across even public cloud vendors. In addition to that, it's all about giving the latest and greatest hardware. So even for NVMe, we're running a Intel Optane P5800X. So these are very premium NVMe drives with high drive writes per day. And the other thing too is a lot of customers have questions. Even you just asked about, how can PMEM actually benefit me or you, right? And that's what the environment is for. So you can find out for yourself, how does it scale up? Never mind scale out. I mean, first you got to start small to really understand how does it even behave for one user, not just a million users. So it's for everyone. It's not just large cloud enterprise. There's a lot of smaller operations where they can really benefit from this, so they can make the smarter decisions based on real tests.
Great. So Tom, I'm kind of a dummy when it comes to this from a technical standpoint, to be honest. And when I see this pitch from Michael, simplicity is what stands out to me. The name is plug and play, but once you get this thing in and deployed and online, it really is dead simple. What's your take from, I just said you were at KubeCon recently. What's the word on the street from the guys you talk to in terms of getting stuff like this day two? So it's on and it's operating, but now we got to use it.
Yeah, I remember a couple of years ago when we were at the last in-person KubeCon, me and you kind of went looking for, appliances. We wanted something that people can just roll out, deploy, and not have to worry about, curating a stack and installing the software and just dealing with those headaches. And so, something like this kind of checks off all those boxes. And we saw a few vendors, but I think they kind of went by the wayside. And so, I think this is really important to the community.
Well, there's not a lot of proprietary nonsense boiled into this thing, right? I mean, it's OpenShift. It's got the whole licensing and support mechanism as part of it, and then of course all the hardware. I mean, that's pulling all those together at once is a little trickier than it sounds.
Yeah, just roll it out. So to the point, bare metal versus hypervisor. What are the advantages one of the other? Is there cost savings going one over the other? What's the advantages going that way?
First and foremost, it's really about choice. We're not saying one's better than the other. It's more about the option to do so if it meets the needs. I think for large operations, it may be tough to kind of make the decision to run on bare metal because they may already be heavy OpenStack users or using vCenter to manage their virtual machines, or even Nutanix. Acropolis actually supports their own proprietary version of KVM as well as Hyper-V and VMware. But what is kind of the common denominator is a lot of these hypervisors are running OpenShift on top. In fact, when we spoke to Red Hat architects, it's one of the most popular deployment models is to run Red Hat OpenShift on top of VMware specifically, and even vCenter. So with that, you're getting governance, right? They already have policies around managing the storage piece, or even memory or hardware compute resources, as well as the network. So VMware has done an incredible job with their NSX and vSwitch technologies. So we're just saying, hey, if you want to run vCenter on these systems, you can, but you can run OpenShift on top. But if not, if you already know how your application is going to scale and run on bare metal, then this is a great option. So what we do to empower that is showing these kind of reference designs, as well as supporting infrastructure as code. So if customers want to provision OpenShift onto bare metal, maybe they have some concern about resiliency. So we actually have a hardware RAID 1 controller just for M.2 drives. So we've really tried to reduce the barrier of entry here. You can even see, not just from a hardware perspective where it's very compact, but even the core OS is Linux core OS that Red Hat purchased. So it has stripped out a lot of the things you may not need for an enterprise, what Red Hat Enterprise Linux offers is a lot of other features, especially hardened security and other knobs and performance tools. But for this is really about the developer. And then once the developers have created solutions for their applications, then they'll want to scale out from here. So this is a very good POC cluster where they can prove everything out, and then they can run a much larger production environment.
Yeah, I mean, you've got a ton of angles. I mean, we talked about CDN, which seems like an obvious place for this to go. But yeah, I mean, if you're an enterprise looking to start in on this new sort of methodology, it would be a pretty good starting place too. And you're right, like on the hardware side, you got Intel Xeon 3rd Gen, you got PMEM, you got Optane SSDs, you got a lot of stuff going on here. So this is a more than stout cluster. So we talked about Jumpstart for just a second, but where do you want people to go? How can customers or prospective customers engage with you on this product and learn more and start to feel it and see what it's like?
Yeah, so they can sign up for the Jumpstart program at supermicro.com/jumpstart, and it'll bring you to this page that I'm already on. So once you register for it, you just put in your information to then sign up, and you'll get an email notification that will grant you VPN access into the clusters. So in this page, you'll kind of just summarize everything that I talked to you about as far as the hardware, as well as network and included subscription. There's even additional software that we're planning to add. So, we have the RHEL as a guest operating system if this was running on top of a hypervisor, or you even have a Red Hat Ansible automation platform. So if customers are already using Ansible, we can set that up as well to run orchestration tools or other provisioning tools for any other software that they want to run inside the cluster. So we just have this environment for initial kind of proof of concept, but we're open to adding additional resources for customers to really try out the solution.
All right. Well, we'll have a link to that in the description on the video, so check that out if you want to learn more. And of course, we've got a dedicated piece where we get into all the information about what Supermicro is doing here and the future for these more solutions-based offerings. Michael, thanks for joining us. This was a great walkthrough, and we expect big things out of you. So I'm sure we'll be back with more information on future enhancements and integrations and all the other stuff you're working on.
Yeah, glad to be here. And just one more thing, Brian. If customers want to learn more, or your audience wants to learn more, there's a full-blown reference design for all the like a production level kind of rack. So they can learn about that at supermicro.com /en/solutions/Red Hat OpenShift.
All right, we'll drop that link in there too, and everyone can come in and check it out.
All right, awesome.
All right, thanks again, guys. This was great.
Thanks so much.
For more information, please visit us at www.supermicro.com, featuring 3rd Gen Intel Xeon scalable processors.